All right, so we're talking about unbalanced forces and how they cause things to accelerate. So in this situation here, is this car accelerating? Yes. So what can you say about the forces? The If you have acceleration, the forces have to be unbalanced. Good. Now, this question here is just a straight calculation, but make sure you're understanding what's happening. If you're trying to determine the net force, it's very simple to just go MA without thinking about what's actually happening here. The forces are unbalanced. Okay, think about hitting the gas pedal. You're at rest, and then you hit the gas pedal. Okay, you apply a force through the car's engine to accelerate. And in this case, you would have 1,000 times 1.5. Okay, what would you get there? 1,500. And the unit for mass is kilogram, for acceleration is meter per second square. You're timesing those. That's really annoying to write, so you put the word or the letter capital N to replace that. And there was still a couple of you on the exam who still didn't put significant digits and units on your test. And actually one of you went from passing to failing just because of that. And unfortunately, I have to deduct you for this because it's tradition. So don't make these mistakes. How many sig digs? Just 2. So you can put 1.5, and I'll just put a little k, kilonewton. You guys okay with that? Kilonewton? Kilo meaning 1,000, 1.5 kilonewton. And the other acceptable answer here would be 1.5 times 10 to the 3 Newton. And you can just think of the kilo and the 10 to the 3 as interchangeable. Are you guys okay with this slide? All right. This question is so famous in physics at the starter level, even at the higher levels. They always put these ones on, whether it's accelerations or for regular forces. Even later, like in Physics 30, we do this. So, and these are easy to get good at, and it's all just an algebraic trick. Okay? So I want you to just think of what's happening here. Car is accelerating. So what does that mean? The forces are unbalanced. Now, the net force, that's the unbalanced net force. I'm going to put that in there. The unbalanced net force is doubled, and then the mass is tripled. What's going to happen to that acceleration? All right, so the force we know is equal to ma. Let's just put that in right now. Now, if you divide out the mass, you can solve for A. And that value is 3. That we know. The force divided by the mass, and that's the net force, divided by the mass is 3. Now, I'm going to switch colors. What do we have to do to that force? Yeah, so we have to go, let's go like this. Twice the force divided by What do we have to do with the mass? So we double the force and we triple the mass. So the original force we called capital F. This new thing is double capital F. Do you agree? And this new thing is triple lowercase m. Do you agree with that? So then what you can do is just slide the 2/3 to the front as a coefficient and write F over m in a bracket. And what do you know F over m is equal to? F over m is equal to 3. So you can do a substitution there. So 2/3 times 3. Those 3's will cancel and you'll be left with 2. Okay, I'll just sneak in some units there. F over m equals 3 meters per second square. And therefore the final answer will be an F over m, and an F over m is in meters per second square. So this is your new answer. So it's about substitution, and it's about plugging in what you know and then doing a little bit of algebra. So the acceleration went down. The force got doubled, but the mass got tripled. What do you know about if the mass gets higher, the acceleration gets lower. And the force doubling just wasn't enough to maintain that acceleration. To maintain that 3 meters per second square, it actually decreased because the mass tripled and the force only doubled to try to compare with that tripling. Question? Oh, there was a flash. I think it's because of the black background. Okay, a force of 350 newtons is applied to a 75 kilogram box in the absence of friction. Determine the box's acceleration. Okay, I would draw a box with a center of mass on the ground, and you have this force applied, and they said there is no friction. Usually you would have an arrow pointing in the opposite direction to oppose the motion. Friction always opposes your motion, so in this case they want you to ignore it. So what is the net force equal to in terms of the diagram? The net force is just the applied force. Do you agree? If there was friction, you would have to put in like a minus force friction. That stuff we're going to do tomorrow. Okay, so right now we're just focused on like probably one force at a time. And that of force applied is equal to 350 newtons. And we know that F net is equal to MA on the other side. So 75 kilograms times A is equal to 350 newtons. This is very simple. Just divide by 75 on both sides. The math is very straightforward, but the understanding is much more important. This 350 divided by 75, pretty sure a grade 8 student could get this. However, the understanding is much more important, especially that top piece. The fact that there is no opposing force, so this F applied in the free body diagram stands alone, and the net force is only the applied force. Okay, I got like 4.67. We got 2 sig digs, so 4.7. Now if the box was originally at rest, what would its velocity be after 2 seconds? So you gotta think back to your acceleration formula. What's the acceleration formula? Why do I do that? A equals VF minus VI over T. Go ahead and try and find that now. You know what A is, you know what T is, and if it started at rest, what do you know the VI was? Okay, so plugging in what we know. 4.7 is equal to VF minus 0 over 2. So it's quite natural. Like, I just put 4.7 on the screen, and then I used my calculator's last stored answer. So like whatever I put on the screen is always like, I can't write every decimal, right? So I just times it by 2 and I get 9.33. That's VF. Because VF take away 0, that's just VF, and then times both sides by 2. You just times both sides by 2. Yeah. All right. This question, I'm going to show you how to do this graphing in 2 seconds on your graphing calculator. So get your graphing calculator out. And I'll show you how to do this quickly. Yeah, if you need to, yeah. You can just borrow one for now if you want, but if your locker's close. Alright. Just going to grab the calculator. Okay, and what I want you to do is just hit second plus into the memory, and then just hit number 4. Second plus, number 4. Imre, hit second plus, and then hit number 4. Clear all lists. All right. So when you go, hit the stat button, and then you're going to hit edit. And then you got 2 lists you can hit. You're going to basically type in this table. But before we do that, we need to think about this question. Which one is the x-axis and which one is the y-axis? And this is very typical for a science student. You have to think of the situation and then decide, like, which goes where. Just hit stat, enter. Yeah, statistics, stat, enter. And then these tables come up. Okay, so a physics student attempts to demonstrate Newton's second law. She pulls a cart with varying force and measures the acceleration. Okay, so we know that a manipulated variable is known as the x, and the responding variable is known as the y. So what's she manipulating? She manipulates the force and then measures the acceleration. So she's measuring the acceleration as the response. So this chart is good. This chart is good, in the sense that the first column is x and the second one is y. Okay, get that typed in, L1 and L2. What? What do you mean you don't know how to use? Type it in. Oh, well, you have to follow along and listen. Stat edit. Stat enter. That's all you gotta do. Stat enter, and then you get here. So force is on the x-axis and acceleration is on the y-axis. Everybody got that typed in? Okay, go to your window now. And you can see my window is messed up, ridiculous from whatever the last thing I was doing on here. But like, what window would you want for those x variables? 0 to 10 looks pretty good to me. And for the acceleration, you know, 0 to 10 looks pretty good to me as well. It's going to get all my... After what? Window, yeah. So I just went to change the window. Because like on an iPhone or a Samsung or something like this, or Android, you would just like pinch pull your window. But on this calculator, you have to set the parameters for the x and y axis. Now go to the y equals. Make sure everything's cleared out of there. I see you had a bunch of crap in there. Make sure it's all clear in this y equals. This is where you would type in functions to graph them. Go up to the plot. So you have to hit the up arrows until you're into the plot, and then just like highlight the first plot so that like plot 1 is highlighted. So after you set the window, go to y equals and turn that plot on. And then if you hit graph, you can actually see them. No, you don't want to use a paper graph right now. So from the beginning, you hit stat, and then you hit enter, and you get to edit your lists. That's why it's called stat edit. You edit the lists. You get the x-axis and the y-axis typed in, but you have to think to yourself, what's the manipulated and what's the responding? In this case, she's varying the force. So that's the thing that she changes, that's x. The thing that you manipulate, that's the input, that's the x. If I only put in a force of 2 newtons, this is the acceleration I get. If I put in a force of 4 newtons, this is the acceleration I get. This is manipulated versus responding. Every science student should have a firm grasp on that. X versus Y, manipulated versus responding. Now you get them typed in. You set an appropriate window. This is like determining your axis on your graph by hand. You know how you have to set the axis, make sure it fits the page? Well, you just do it in one click. And then for y equals, you just turn that plot on. And then you can hit graph and you can see it. The only problem is we don't have a graph yet. We only have the plot. So identify any outliers. Which one of those do you think is an outlier? I think at the 4 newtons it might be a bit of an outlier. I think it should be this second box. Do you think it should be a little bit lower? So maybe there was some human error in that situation. But does it look like a line of best fit would approximate that data? So how the heck am I going to get a line of best fit in there? And then this is where I lose people. So maybe you want to jot this one down. Stat calc. Okay. So stat. And then you got to arrow over to calc. And then you got to pick number 4 there. So hit the button 4. Hit the. Why do you think it's number 4? What does that say? Line reg. This is a linear regression, it's called. And it's ax plus b. You guys recognize that from math? What is that? mx plus b. Okay. So hit enter on number 4, or just hit number 4. Okay. And that's the equation. That's the equation. Didn't get that one? If you have the newer calculator, you got to go down and hit like calculate or something. Did this thing pop up after? Okay, so you got to hit stat and then hit over. And then there's 2 you can pick from. It's number 4 or number 8, but just hit number 4. Okay. So here's the equation. Here's the equation. Y equals 0.58 x plus 0.4. This is the equation. I could type that in if I like. 0.58 x plus 0.4. Hit graph. And there's the line of best fit. So stat, hit the calculate. Oh my gosh, guys. You're supposed to be the tech generation. You hit stat. I also have it written down here, by the way. You hit the over button. And then it's number 4. And then you hit enter. If you have the newer calculator, it like prompts you in a nicer menu that's much more, it just tells you like, what do you want? And then what you can do is you can go into y equals and type that in. And you can see the line of best fit. Well, actually, when I go to y equals and type it in, and if you're new to this calculator, which you shouldn't be in Physics 20, you should have had a whole semester of Math 10, Science 10 using this. X button's right there. Type it in, hit graph, there's your line of best fit. What are we always interested in physics for a graph, especially a straight line graph? Slope. We're always interested in that. Okay. What did they gave us the slope? This is the slope right here. That's the slope. Do you guys see the equation? Do you guys remember in math class, y equals mx plus b? What does the m in this formula represent? Slope. Now in this calculator, they use a, right? ax plus b. So a is the slope. A is the slope. So right here, a, 0.58, that's the slope. Now if you think back to these tables, this was the x, and this is the y. Okay, so on your chart, you need to make sure you've put x on top of force and y on top of acceleration, because those are the manipulated and the responding variables, respectively. Now watch the magic. I know that force equals ma. This is Newton's second law. This is a physics principle, which is always true. The net force is equal to ma. When you write y equals mx plus b, or in this case y equals mx, because this plus b you don't need, because as you can see, there is no extra term. That's just from the lab. It's just an extra piece of data that just doesn't matter. This y value is the dependent variable. Do you see that? It's isolated. The y value is the dependent variable. It's isolated alone. Which one's our y value? Acceleration. So you have to isolate for the dependent variable. As in y equals mx. Okay? Which one's our dependent variable? The y is the acceleration. So acceleration equals f divided by m. Do you guys, you're with me here? So the a is the y, and which one's the x? The force. So what does the slope, and I'm just going to make this, instead of writing mx, I'm going to put slope x, because it doesn't make sense for me to say mx plus b in physics class, because what does m stand for in physics? Mass. So I don't want to get you guys confused with variables. I know that in a linear equation, it's y equals slope times x. And you could call the slope any letter you want. I'm just going to call it slope. So what is the slope equal to? If I rewrite this, it's 1 over m times the force. Do you agree? A is y, f is x, and the slope equals 1 over the mass. Slope equals 1 over mass. Therefore, mass equals 1 over slope. And the slope is given as 0.58. So the mass of this object is 1 divided by 0.58. Okay, that's the mass right there. So if you plan on taking Physics 30, this happens all the time. You're going to get data. You have to connect the data to the physics principle. And then you have to manipulate the physics principle, connect it to the slope. What does the slope represent in this situation? In this case, the slope represented 1 divided by the mass. And then you solve for it. This will not get tested in Physics 20. Even though I could, I don't. But this is a little bit of a snapshot of Physics 30. I just said it won't be.
I'm sorry, I'm just like stressing because I can't do this.
So just because it's on the test means you're not going to learn it? Is that what you're saying?
When we have to learn it, then we'll learn it.
Oh. So you just guide your life based on how you get tested? Oh my gosh.
Why? Everyone does that.
Really?
Guys, you know you guys do the same thing. You guys do the same thing. Putting you on the spot right now.
Yeah, it's tough, especially when you only see it one time. And plus you're like trying to figure out the calculator, not even really thinking and listening to me, right? You're more trying to figure out that damn calculator, right? So anyways, we'll come back to that type of problem again. Okay, let's keep rolling. Please read the next one while I switch to the iPad. Okay, you got a three-way tug of war. Determine the net force on the acceleration of the rope. Okay, what I would do, draw a dot. Think of that as like the center of the mass, and then draw in these vectors. So F1, 30 newtons east. Which way do I draw that? To the right, and that's roughly 30 newtons. Turn off the lights, I can see that better. Now, 20 newtons north, and then 50 newtons west. Do you see how it's more than one dimension? Let's do the simple one. What's F net in the X? $30 to the right, 50 to the left. Who wins that one? Okay, so negative 50 plus 30 equals negative 20. And F net in the Y? It's just the 20. So you have two components. One is to the left and one is up. So you have 20 left, and then you have 20 up. So you would have to find the resultant, because those forces are in components. 20 left, 20 up. Okay, doing this.
Wait, I just did like this, like F net equals 30 plus 20 plus negative 50, and I
Yeah, that's a big mistake, because those are in different dimensions. You can't add wests with norths. Does that make sense? You have to go component-wise. X's with X's, Y's with Y's. Okay, the resultant, using Pythagorean theorem, 20 squared plus 20 squared, using the square root, I got 28. Okay? And then using inverse tangent of the opposite and the adjacent, they're the same, so it's a isosceles triangle, so you get 45 degrees, and this is north of west. So that's the resultant force. In this three-way tug-of-war, this thing's actually going to get pulled at an angle, because there is some north that's unbalanced and some east and west. So how would you find the acceleration? The acceleration is just the force divided by the mass. So take your net force and divide it by the mass. Okay? So net force divided by the mass is the acceleration. Where did I put my pen? There it is. So F net equals ma if you wanted to find the a divided by the mass. F net would be this 28 divided by the mass, which is 175. I got like 0.16. 2 sig digs, 0.16. 0.16. And the direction of this acceleration will be the same as the direction of the net force, so 45 degrees north of west. Any questions about that? So there's lots of physics that we've gone through today. Hopefully you review it. The one that we did with the chart and the graph, I'm going to continually repeat that process all semester. I never test you on that. I will only test you on that in Physics 30. So you're going to get it shown to you in Physics 20. If you make it to Physics 30, I'll formally show it some more and actually will test you on it as it shows up on the diploma. This slide just reiterates the fact that if you have two components, x and y, you have to be able to resolve those components dimensionally. Like x's go with x's, y's go with y's. You can't add norths with wests. You can't just go 20 plus 50. Like, it doesn't work that way. Okay, you have to resolve the net force in x, the net force in y, and then once you have them separately, then you can do the Pythagorean theorem on those two components, right angled triangle geometry. The first and second law, you absolutely must understand. This is like the underlying physics, the physics principles. Okay? So, again, you can't just do math in this class. You have to think to yourself, okay, what's happening? What's the physical situation? How do the physics apply? And then you apply the math. So, you guys can try this one. As an exit slip, try this one. Yeah. All right. So let's take a look. So f net y, 8 plus negative 8, 0. And f net x, (18 plus a negative 10). Now just look at the picture. Do the 8s top and bottom kind of cancel? So that's balanced, right? So will there be any acceleration in the y component? No, because forces are balanced in the y component. But are the forces balanced in the x component? It's like I got a T-Rex arm on this side and a long, strong arm on this side. Who wins? By how much? 18 beats 10 by 8. So the only unbalanced force is this 8 newtons. So this is the unbalanced net force. And then you can finish this off. F net equals ma. 8 equals 2a. 8 divided by 2 is 4. Writing it properly. And in which direction? I guess I should have wrote east or right, whatever. There's only one more to go. I'll leave this slide up here for a few more seconds. Okay, last one. Thanks for bearing with me on this long lesson. Okay, two people are pushing a broken car. The first person pushes with that force, the second person pushes with the other force, and then friction opposes that in the opposite direction. Determine the acceleration of the car. Okay, so let's draw that free body diagram. All you gotta do is draw a box, or a dot, whatever you want. That's a flat line. Here's the center of mass. If two people are pushing it, which way do you want to push? Let's push to the right. One of the forces is 425. What's the other force? 250. So you wouldn't draw it as big. It's a smaller force. So we have two forces applying to the right. So which way should this thing move? So which way would this thing move? It would have motion to the right. Now, what opposes motion? Friction. So friction will always point in the opposite direction of the motion. And in this case, it has an amount of 380. And I'll just put here opposes motion. The force of friction. It opposes the motion. So just think of this as like a fight. On the right side, that would be 675. And on the left side, you have 380. So who wins that fight? And by how much? So F net is equal to 425 plus 250 plus negative 380. $425 plus 250 minus 380. 295? Positive. So 295 newtons to the right is the net force. If you wanted to find the acceleration of the car, all you would have to do is expand F net to its formula ma. And then all you have to do is divide out the mass on both sides, which is 650 kilograms. Have a great day, you guys. I'll see you guys on Wednesday. Maybe you'll see me in the school tomorrow, but I won't be teaching you tomorrow. As you leave, I can put up the homework. It's the same homework I gave you over the weekend. The same homework I gave you over the weekend, make sure it's finished for tomorrow. It's 1 to 11, page 71. Absolutely. I'm actually going to be posting to School Zone in second block here, so you can check at lunch on School Zone.